All right. Hey, everybody. Welcome. How are you? This is part 3 of our Kubernetes stream. I hope some of you who were able to attend part 2 and part 1 might be able to come and hang. But yeah, if anyone out there is in the audience and can hear and can give a quick mic check, that would be amazing. But yeah, so let's go ahead and start with an introduction. So my name is Steven. I am an MLH coach, and I've been hacking for almost 10 years now. I thought that was kind of a fun milestone to celebrate, given given the year. And so, yeah, why don't we check into this event? As I've said over here, it's really important that we get your check-ins because we want to see, what are folks interested in as far as streams go. What kind of stuff do you want to see? And yeah, I know it's part 3, so there might not be as much interest in it, but hopefully there's still some folks who are sticking around from all those previous parts. And don't worry if you didn't catch parts 1 and 2. We'll be going over a little bit of that as well, okay, in the streams. All right. So first, I wanted to give you a welcome back and ask for a poll. So the poll question is, how comfortable are you with Kubernetes so far? And so if you're not at all, you can type in the chat a number 1. If you're getting there, you're not quite feeling great about Kubernetes, but you are getting there, type a 2. And then if you feel great about everything we've seen, then type in I'm cruising in the chat, or number 3. All right, so Jagadish says number 2. Yeah, I think this is probably going to be the most common response because we are only a couple days into Kubernetes, a couple streams in. You're not going to be cruising unless you are really an expert or it's just clicking for you. So don't feel bad about getting there, but hopefully you've got some knowledge from our previous streams, and that's right the sweet spot where we're trying to be. So awesome. Thank you for bringing that out. And I'm going to give a quick part 1 recap here. We learned the core Kubernetes components in part 1, and that was pods, nodes, deployments, replica sets, and services. We talked about all of those things in part 1. And we practiced creating YAML files, which, as you may have learned in our previous streams, are very related to JSON. They're very similar to JSON, but they have many sub-levels that are indicated by spaces and tabs. And we created those YAML files to deploy applications, to scale them, and to perform rolling updates. And so, yeah, if you feel so inspired to answer this question, if you don't, it's okay. But what was one thing you found most surprising about creating the first deployment that we did on part 1? You can share that in the chat if you'd like to. But actually, we have this documented on GitHub, thankfully. So I'm gonna send that out to all of you. Here it is. So if you check that out, it's part 1, all the files we did in part 1. And I'll show you with my screen, by sharing my screen, I'll show you what that looks like. So let's see, I'm going to shrink the size of this window a little bit so it's easier for you all to see the text. That text can be pretty small on your end. Okay, so hopefully this is better. You can see where we have, for example, config map, nginx deployment, nginx service.yaml. Yeah, hopefully that's better for you. And just to start off with our deployment, we talked about some of these sections here. We always have to specify our API that we're using, our deployment, the fact that it's what kind of Kubernetes component we're going to use, in this case, a deployment. We give metadata so that they can reference each other, the Kubernetes deployment components. And then in our spec level here, we tell a lot of information about how we want these pods to look in our deployment. We give it the replicas, so that's how many, 3 in that case, different clones of our pods. We give it a label, of course, and we tell it, what kind of software we want to run. So in this case, we're running Nginx, the latest version, on port 80. And we mount a volume. So we'll talk more about this because we didn't talk that much about it in part 2, but we mount a volume. And that's where we have our permanent storage. And then here we have our environmental variable, which, if you remember, that comes from our config map, okay? And so we'll talk about our config map soon. But then we allocated some resources to our pods. So we gave them 100 millicores and 128 megabytes. And then we specified some health checks. So we gave a readiness probe and a liveness probe to make sure that our clusters were, if one of our pods were to break down, it would be able to be restarted within a reasonable amount of time automatically. And then we talked about our volumes, as I just mentioned. So we will get all back into that a little bit, but the next thing I want to talk about is our config map. So we discussed this too. It helps us keep some fixed variables and fixed content that we can then access from different deployments or components within our Kubernetes. So here, for example, we're using index.html. All right, and so we actually gave this welcome message. And then in part 3, we take the look, or sorry, not in part 3, but in this service YAML, we gave some metadata about our services. We gave that a annotation, and we told it that it should access through a node port, meaning that it could allow for some external use of our pods across the port 80, across the TCP protocol. So if you ever see node port, you know that it's enabling an external IP communication. Okay, so that was our part 1. And then we talked about part 2. And so in this time, we advanced into networking, persistent storage, and security. And we did a little bit of work on this. We set up services and ingress for routing. We configured our persistent volume claims for data persistence, and we learned a little bit about RBAC and network policies. And so let me find that link for you. I'm going to find, actually, let's not give you a new link, or I'll give you a new link, why not? So it's just the same repository, but in the part 2 folder. So if we go back here, let's see. You can see we just back out of this Kubernetes fun into that directory, and we type part 2 here, and we can see all the great stuff we did in part 2. So first, I want to talk about advanced service.yaml, which is where we explored some other components. So we explored cluster IP, we explored node port, and we explored load balancer. Okay, and just to give you one more idea about what these things are, what is load balancer, what is really what is all this stuff? I'm gonna share with you all a slide from part 2, which I thought was really informative for this stuff. It's slide 122 of my deck. And you can access it in that same GitHub repo. You can access these slides. They're called the part 2 slides .pdf. And so I'll talk to you about these different networking components. So we could make a cluster IP, which is where the default service type that exposes the service on an internal IP is structured. So this is for something like, for example, if you wanted to communicate between a database and a front-end server, you could allow the the database to be exposed on an internal IP address. That way, people from all over the world could not just go ahead and access that, right? You would actually need to decluster IP. And then node port opens a specific port on all nodes so that the service can be accessed externally, right? So this is where we basically are allowing external access to our data. So we could serve a web server, for example, to some clients, to some users. And then load balancer is the third one that we did discuss for this advanced service YAML. And that's where we could integrate with a cloud provider load balancer to expose the service externally also. So load balancer is where, if you have a lot of traffic and it's all being routed to one particular resource, you could distribute that more evenly across multiple resources, right? So that's how the load balancer works. And then ingress is a collection of rules that allows inbound connections to reach the cluster services. And we did talk about ingress. I'll mention that a little bit in this YAML that we'll look at. So let's have a look at these GitHub files. So we go to nginx ingress.yaml, and you'll notice something different about this. So the API version is the networking subdomain at Kubernetes. So we have a networking API for this ingress type YAML configuration, and we give that some annotations, of course, so it can match up and be referenced throughout the project. But we give it some rules too. So, for example, we had an nginx.local host, and then we had several paths, which are on the main path, the main directory. And we had a service which was called advanced service. Okay, so we just we have it reference our advanced service. And if you don't remember what the ingress is accomplishing here, we'll actually check that out. Let me pull up that slide. So if you don't remember what ingress was doing, it defined a rule that directs traffic from the host to our service. So you could imagine our host being nginx.local, and we want to direct it to our advanced service, which could be on any number of different routes. So we're using ingress to make sure that whenever we go to nginx local, all of that traffic gets routed to our advanced service, which can then expose us to resources. Okay. So that's what ingress was. And then if we go to our GitHub, we have a few more files to take a look at. For example, we could talk a little bit about our persistent volume claims. Persistent volume claim is where our pods are making a claim on some persistent storage resource. So they're saying, okay, we need to have a little bit of data, gigabytes or megabytes, to save someone's user profile. And so we can use that to save their logon information, for example. And the access modes is telling us that we'll have read-write capability. And this is saying it's a request for 1 gigabyte for this resource, right? So that's how persistent volume claims work. And then we also talked about roles and role binding. So this is where we created a role called pod reader, where we only allowed read access. It had only core API access, and pods it could use to get, watch, or list. That was it. So that's really how we define user permissions. And then we finally talked a little bit about our stateful set, which makes a static connection between some web address and could route you to the same static pods each time with the host connection. And there was actually one other thing that I forgot to mention, and that was our network policy. Okay, and so our policy is really telling us about what kinds of connections will be allowed. And so we created something called deny all. And that was the name we gave it here. And we said that we would give, for example, first pod selector an empty set. And when pod selector is empty, it matches all the pods in the namespace where the network policy is applied. So if we wanted to target specific pods, we could, but this just targets all pods in the namespace. And then we said policy types ingress and egress. So we're applying this to both ingoing traffic and outgoing traffic. Okay, and since there's no rules defined here, that's why it's a deny all policy, because we could implement rules, but we did not. And we'll talk a little bit more about rules in part 3. So here's one example we'll look at in our slides. Let me, we can switch to the editor. Oh, okay, great. We can already switch to the editor and check this out. So I'll show you. If we wanted to make a rule for ingress, we could say we allow ingress from, and we'll use our pod selector tool to select any pods that match the following labels where the role is front end. So this is our allowed source pods from some traffic. So we're allowing traffic from the front end to come through. And we would want to put some kind of ports that we would allow traffic from for safety reasons. So let's allow TCP traffic across the port 80. All right, and we won't commit those changes because I just want to leave it like this for now. But this would just be an example of some way you could add some policy. So I shall copy that in. I'll make a little folder now for us to put some of these examples of network policies so we can better understand network policies. Just going to name them like policy example 1, policy example 2, and so on. So I'll give another example, which will allow all pods to access the egress. Okay, so this is allowing ingress on a specific port. So we're only allowing ingress to occur from front-end pod, any front-end pods. And now we can allow all pods to access the DNS. So we'll delete our ingress rule. We'll just go with an egress rule. And we can say to namespace selector. This will do all namespaces, which is going to translate to all pods. And we can have some ports too. So we'll say protocol UDP. You can just allow that type of traffic to the domain server. And so you could just restrict that however you want. So I'll put this as an example. We'll say example 2. All right, and then I'll make a third example here too, where we will do, okay, so let's actually call this one allow all pods to access DNS. We'll call this one front-end ingress. And let's do one for IPs, okay? So we could do one for an IP address. So we go to egress, and instead of a namespace selector, we could do something called IP block, which is where we place an IP block so that we allow traffic from the following ports So we go from 0 to 24 here. And that's our external IP range. So this is a very, you could think of this as like when you allow traffic on Netflix, let's say, there's only certain regions where they'll allow access to certain files. Like if you want to watch a movie that's only released in, let's say, United States, you would have to have an IP following these range and block all the other ones. So I'll put that in as well as another example. And I think those are all the examples we'll do for now, because I want to keep going here with our slides. So let's see here. We were on, I think, slide 56, where we were doing a recap of these things, and we covered basically all of this stuff from part 2. And today, let's talk about what we'll discuss for today. So we're going to go deeper into how Kubernetes handles storage and configurations. And we're going to discuss some topics that we discussed before, but in more detail, and some topics that are totally new, like secrets, for example. We have not talked about secrets yet, so we'll do that. Okay, and volume management as well, we could discuss. So let's continue here, and we will talk more about config maps. So config maps are a way to decouple configuration data from your application code. So in other words, instead of hard coding some settings, right? So in the welcome message case that we looked at before, we could hard code a message, but instead of doing that, we store key value pairs. So like the welcome message is stored in that config map and then mounted into the pods. Okay. And why might this be useful? Well, there could be a range of different things you want to put in your config map. Could be, specific policies that you want to roll out to different, clusters. It could have to do with, just updating content in the case of the hello message. And here's an example as well in the slides. If you have an application that needs to know the URL of an API endpoint, you can store it in a config map. All right. So that's just one example of something. And so we also wanted to talk about secrets, which are similar to config maps, but are used for sensitive data. And so, for example, if you have an API key, right, not just an API endpoint, but an actual API key that is going to charge your account whenever you access it or use it for permissions. And it's going to, you're not going to want to keep that in an unencrypted format. So secrets get stored in an encoded form, and we handle those with great care. And we'll talk about them today. So then another thing to mention is volume management. Okay, so volumes in Kubernetes provide a way to persist data beyond the life of a pod. And so persistent volumes and persistent volume claims work together to give your application stable storage. And we did talk a little bit in our earlier parts about what these are. Let me review that a little bit with you all first here. So in Kubernetes, data persistence is managed via persistent volumes and persistent volume claims. So the persistent volume is a piece of storage on that cluster. So let's say you have 100 gigabytes. You could provision one of your gigabytes, just one, as a persistent volume for some cluster, for some application of the cluster. And then a PVC is a request for storage by a user. So someone who is using this cluster could claim or claim some PV, some persistent volume, and they would ask for a specific provision of that and have some particular reason why they want it. All right, so we can talk more about that in the future. But let's talk about a quiz here first. So what might be one reason to use a config map instead of embedding configuration directly into your application. So if you can think of a reason why, type it in the chat. I'll give you a minute to think about this. All right, so it looks like we have a few answers here. First one from Ilya, makes it easier to update configurations. Absolutely, because you think about it, you only have to update it once. And then you could apply that same config map to a bunch of other scenarios. Another one from Jagadish, flexible. Yeah, it is flexible because once again, you only update once. And this is also very key, what Dream King 60 Stephen mentioned, decoupling. So let's say you wanted to share your configurations using some Kubernetes, but you don't want to share all of your system-specific information. You could just share the configuration files without sharing a config map, right? So, and then you would create a custom config map for the new scenario. So, those are all really good reasons. And what about secrets? Why are they important? Let's give another minute for looking at that. All right, looks like we have some answers here. Helps hide sensitive data like personally identifiable information. Totally. Hides keys and API tokens, definitely. So good job in remembering all this stuff. And so let's actually create a config map that stores an HTML file. And this is actually an exercise from before, from our very first workshop, but I wanted to redo it so that we can reinforce that. So let's take a look. So we'll open our editor to create a file named configmap.yaml. And so I will open that for us. It's going to be in our Visual Studio Code. see that here. So I'm just going to close a lot of these other files because we have so much open from our previous workshops. And I'm going to definitely share all these policies with you. In fact, let's take a minute to get those slides shared too, because I want you all to have access to our slides. So I'm going to create a little PDF for all of you, just the slides we have for this workshop. All right, let's see here. So we're going to put Kubernetes part 3 in there. And I'll even throw some of my files from today so far into there. So we had part 3. And all of our network policy examples. And I'll upload this to GitHub. So here's the start of part 3. I'll send it to you all so you can have access. So there you have it, Kubernetes Fun Part 3. And that should give you access to all of the good stuff we have. Including our network policy examples. If you go down into this folder here, you can see there's some network policy examples. But what we're going to put in here first is that config map code. So we're going to just create a new file called config map here. .yaml. I don't want to put it in network policy examples. I just want to put it in part 3 because that's going to be kind of a separate thing. So yeah, for this config map, we're going to put the following. I just pasted this in, and I'll make this a little smaller so it's easier for you to see on your screen. Let's see here. There we go. So you can tell now that we have our config map, and nginx config is the name we gave for this. And we just threw in some index.html here. So this could just be some thing we could access. All we have to do is use this key anywhere in our Kubernetes, and it will return this value, which is this HTML content. Okay. And so we won't go too far into that because we already discussed it before, but just wanting to reinforce that for all of you. And the next thing we'll do is a more advanced concept, which is to apply the config map. So we use apply to do that in our terminal. So I'm gonna actually use the terminal inside of our VS Code. I haven't been doing that, but let's go into part 3. And we're going to type the following. We're going to type kubectl apply -f config map.yaml. Okay, so we type enter there. And it told us connection refused. I'm not sure why exactly, since we were able to do it before just fine. Let's Seems like we could ignore this error though somehow. So let's just ignore that for now. Maybe it'll go away for us. But there's another advanced concept we didn't cover last time, which is getting config maps. So we did this get config maps. I'll type that code in. And when you type a YAML keyword, it allows us to access the YAML content of that. So let's try that in our command line. Maybe we should be, oh, I don't have my Docker started up. That's the problem. Okay, let's start my Docker engine up. Then it should work, I think. So if this error happens to you, I think it's probably due to the fact that the Docker is not running. Minikube start. All of my containers were, yeah, they were closed out between part 2 and part 3. So how I got this running was I started up my Docker and then I did Minikube start, and now it should be working. Yeah, there we go. Just forgot that I turned off my computer in between, so all this stuff wouldn't be running anymore. But yeah, so then we can type our config maps and we can get the YAML behind that. So that's a really useful thing to know, is you can just do -o and then YAML. And I pasted the command in the chat too. Okay, and so let's continue along and create a secret. So this is a new concept we didn't cover before, creating a secret. And the way we do it is through a file called a secret.yaml. So let's open up our VS Code and we will build that. So we'll throw in our part 3, our secret.yaml. It's empty for now, but we will throw that in there. It'll have API version v1, and we're going to call it kind secret. And so I'm going to give it a metadata, and I'm going to call it an API key secret. All right. So we'll just make up a random API key, but we're going to use type opaque. And what does that mean? Well, the type is telling us what kind of level of encoding we want there. And so let's continue here, and then I'll specify a little bit more what I'm talking about with that. Sorry, I lost my note there for a minute. So the next tag we'll put here is data. So we want to put data, and then we would just put our API key. So let's just put this random API key. I don't even know whether that would have anything related to any API, but if it works for you, that'd be so cool. But opaque is just the most default type of secret that you can have. And so expects base 64 encoding. So this expects base 64 encoding. That's the default type of encoding used in Kubernetes. Okay, and so then we can apply the secret by going into our command line, typing kubectl apply -f secret.yaml. So our secret is now created, and if we wanted to get our secret, you type kubectl get secret API key secret. And how do we access YAML again? That's right, we use -o space YAML. I'll type this into the chat because this is somewhat of a new concept that we didn't cover in our previous parts too much. So when you type that in, you'll be able to retrieve your secret here. All right. And so that's sort of how we go with the secret. And then we will talk about config map next. So, sorry, we'll talk about persistent volume claim next. So this is our PVC once more. And we'll create a file called pvc.yaml. So I'll show you that in VS Code. And so we'll add a new file here, pvc.yaml, and we'll write the following. So we'll write API version v1, kind persistent volume claim, and we'll give it some metadata to let the rest of our cluster know where it can access this PVC resource and spec it out. So let's spec it out with some access modes. So we'll give it a read write once access mode, and we'll give it some resources. This looks fine to me, 1 gigabyte. And I'm going to give it a storage class name, which we never have done before. But this is just telling us what kind of storage we want here. So it will be, let's just use standard for now. And in case you've never seen this before, the idea behind the storage class mode, so it's telling Kubernetes exactly what kind of storage we want. There could be backend storage like solid state drive or something on your local machine. There could be some AWS resource that we could use, but standard will just give it whatever whatever resources it has, if you don't want to be specific about that. Okay, so I'm going to use a lowercase. I think you have to use lowercase. I'm not sure though. But let's save that PVC, and we'll apply it just like we have in the past. So we use apply pvc.yaml, and then we can verify using get pvc and nginx-pvc. All right, so we use this command to verify that our storage claim was bound. And so, yeah, there we go. So now let's continue along with our slides. And we're going to deploy our nginx pod with persistent storage. So we'll update our nginx deployment to use this PVC. So we're gonna take the nginx deployment YAML, and we will add these volume claims to it. So let me create that for you, actually. Let me create that for you real quick. We're gonna pop into part 3 and create a nginx deployment.yaml. And we'll paste that in. Okay, so here's what we have. And it looks like we have a PSA from one of our community members, Basic. Secrets are not secret to anyone who has cluster admin access or role-based secret read access. They're base64 encoded, not encrypted. Exactly. So base64 encoding, thank you for really highlighting that. Because if we look, let's see, where did we have this? Yeah, if you look at the terminal here, we were able to run this command, and we were able to access that value. So really, really good point there. Thank you for making that Basic. So yeah, we have our nginx deployment here, and the way we could add this as a volume claim is we add the following. So under volume mounts, we would add a config volume and mount path. So let's just say as volume mounts, and we'll replace this. I wanted to write config volume, And this is fine to keep the mount path as it is. I believe that should work. It might be one level too high. I'm not exactly sure. Sometimes I get really confused with the levels here. And then under the pod spec, which is the same, oh, sorry, so this is in the container spec. Yeah, so exactly. So let's see here, resources, it should be, yeah, that should be right. Under the pod spec, we'll add the volumes. So this is the same level as containers. So let's see, spec is 1, 2 levels, so it should be 3 levels in pods. And we will put our name. So we're going to put config. Let's see, we'll just write volumes here, actually. I don't think we need anything else here. I guess it's fine to have a name, it doesn't really matter. And we'll have config volume, persistent volume claim. All right, Nginx PVC for persistent volume claim. Okay, and let's double check here that we're on the right levels here. So, yep, that's about right, it seems. It should be on the same level as containers. And then the other one we put, I guess we didn't have it in this example, but we did put it in on this volume mounts. Might have had that in part 2. I can't remember, but yeah, let's try and save this, and I think it should run okay. We can try, of course, to do kubectl apply nginx deployment.yaml, and we'll see what we get here. Okay, looks, dang, it's not working, but we can always use our Copilot to fix the levels. I always mess up the levels here. It looks like it's better now. So that's, thank goodness for coding assistance, right? Helping us with our levels in the YAML files. So now we're configured and ready to go. And we can describe our pod. So we'll do kubectl get pods, first of all. And then we can do kubectl describe pod. And we'll look at one of them. Just copy the name and paste it below. You can see it tells us everything we need to know about it. And you can see our volumes are put in there now. They're right over here, our config volume. And so on. So that's just a good thing to keep in mind. And we'll continue along to securities and access control. So we will have a quick quiz questions about this. We will give some of the answers here. So what does RBAC stand for? All right, so since I didn't get any answer, I will just tell you it stands for role-based access control. And which command is used to create a role in Kubernetes? This is a throwback to part 2. All right, so we create a YAML file, and then we apply it using kubectl apply -f and file name. So this just essentially updates the version of the YAML that exists in the cluster. Okay. And what is the main purpose of a network policy? Why would we want a network policy? This is something we really pressed on today. So maybe you'll have an answer for that one. All right, so for this one, it was to control the flat traffic flow between pods. So, we could, for example, block IPs or restrict ingress or egress traffic through our services. So that was some of the reasons we would want to restrict traffic through a network policy. And here's a fourth one actually, fourth quiz question. Why would you want to use secrets instead of config maps for sensitive data? And we have an answer here. Secrets allow for encryption. And yeah, basically they add an extra level of security, although I think Fasik made a very good point here, and maybe I used the word encryption when I shouldn't have explaining this, but um, it's encoding. So we're not using RSA encryption. We're using base64 encoding. So it's a little bit different than encryption, and you might want to look into the distinction to see if it would still work for your security purposes. But yes, it is basically allowing that higher level of security. So in that sense, the answer is definitely on the nose. So good job, everybody, with that. And yeah, now we will talk a little bit more about configuring a secure cluster. So we're going to dive a little bit more into roles, which we already did a little bit of before. And so we're gonna keep on that and just emphasize that a little bit more. Okay. And so here's some common problems. So we often want to create a role. Okay, and so if we look at our part 3 here, I'll show you how to create a role. And so we'll use role.yaml just like we have here. And we're going to use a different API version here called RBAC. Remember, that's going to be for any kind of role-based authentication. And then we'll use some kind. We'll say this is a role YAML. And we'll give it this name called pod reader, just like we did in part 2, okay? And we'll give it a namespace. So we'll say that's the default namespace. And some rules. So they could include that we access the core APIs only. That this applies to pod resources, and that it will allow the following verbs. Okay, and some further response here from Fasik. Seems very knowledgeable about this subject, so thank you for sharing your knowledge about the secrets. So secrets allow for RBAC on the secrets API endpoint. and they are mounted with read-only file systems permission. Let's go back to here. This is to avoid some privilege escalation, so long as the container process drops its root privileges after reading the secret. Okay, so saying that when you design the container's security model, you should have the container process drop its root privileges after it reads the secret. That way it wouldn't be able to essentially read that file. So very, very good. Very, very good comments there, and thank you for that. Yeah, so we are getting into some of these cybersecurity questions here. So very cool and very important to remember. And we are designing roles now, so maybe you can take this one step further and implement some of these advices. But let's continue along and create our role binding YAML. And we can explain what is this and how is it different? How is it different than role? Well, role binding is a little bit different. So it's going to grant access to a role and tell us exactly who can perform the actions that are defined in this role. Okay, so we're going to create a role binding YAML. Let me get my slide up for you so you can take a look yourself. Create a file called rolebinding.yaml. Do that here, rolebinding.yaml. And it's going to be the following. So we will use the same API, I believe, from before. Well, I've got to make sure that goes into the part 3 here. So yeah, it's the same API as before. But we will use role binding. And we'll give it some metadata just to name that. It's totally fine to just have the autocomplete for that. And then we'll have some subjects. So first, kind, we'll have it as user. So we'll say all users get this role. And we can say API group. And so API group is going to it's going to tell us what API to reference here. So this is exactly what they were saying earlier. This belongs to the RBAC, resource role-based access control. And then we'll have role ref. So role ref is telling us which role should be assigned for this this type. So for these types of users, we would put the pod reader role. Okay. And so that's how we would define our role binding YAML. And then we have our next thing, which is just to apply these changes. So we'll just use the apply command to apply these roles and role bindings. And so then we will use the kubectl get role binding read pods, and we'll use -o YAML to check that out and see what it looks like after we go through it. So let's check our Visual Studio Code here. So we use kubectl apply -f role.yaml, and then we will do role binding as well. Looks like we need to change something. I wonder what the issue is here. If anybody can spot it, let me know. Oh, it looks like I didn't put a name. Oh yeah, so that's important. So we need to also put a name. So this is just going to tell us basically, you know, a resource identifier. So it doesn't really need to have any particular name. Let's just, for this one, let's just call it example user. So this is just our example user. We'll save that and run again. Try running again in our thing here? Unsupported value. Let's try to fix here. Sometimes fix can help us when we get stuck. Oh, it was missing namespace as well, which could just be default. So let's try that and see if it fixes our problem. Doesn't look like it did. Yeah, even though it thought it did, it didn't. So let's try that one more time, see if we can fix this problem. See what it's changed, if anything. So it did work that time. So let's see what the difference is between my old code and this new one. So this is my old code. I saved it so we could actually look at the difference. So the top is not different. It did change this somehow, pod reader binding. So maybe that was the difference. It needs to match the role name, perhaps. This is all the same. And this is the same too. So I guess maybe it just needed to match with the pod reader role and say pod reader binding. I'm not sure. I didn't know that, but it works now. So we can use that command I told you about. So get role binding, read pods binding, and we can check this out and see if it worked. And it looks like it did successfully write that through. All right, so we can continue along with our stuff here, and we're gonna move on to what we call network policies for security. And so we talked a little bit about this at the beginning, but we're gonna re-emphasize that. So we can go back into our Visual Studio Code. We take a look at these network policy examples. And so we talked a little bit about ingress and egress policies. So for example, we could allow DNS access. And the way we do that is because we're allowing all of our pods to access that DNS. So that would be egress. And so we would put a policy under egress to have a namespace selector. So we're just going to select all the pods that we have and allow access over UDP port 53. And then another thing we could do is allow front-end ingress. So we could just permit an ingress policy here, where we allow source pods from the front end to come through TCP 80. And then finally, blocking IPs. So this was another thing we discussed. And to do that, you want to just create a file for network policy. Okay, so you would just have a YAML like we did, and we would apply it and get network policy. All right, so what would be a reason why we would want to deploy a default deny network policy? Why would we just by default deny traffic? That doesn't seem very nice to people. But let's just see. How would that help? Hi there, Kosu. Good to see you. It's all right that you joined late. Yeah. So mostly we're reinforcing some of the things from part 3, adding a few of the other network policies. But Sandra says, can you share the slides? Absolutely. So today, actually, I have it all on GitHub. So let me throw that into GitHub for you. Let's see here, part 3. it should be updated in GitHub now. And so I'll send that to you all. Oh, great. Just changed your username. No problem. Welcome. Glad you could join us. And yeah, thanks for attending last session. So this is the GitHub directory, Sandra. If you're looking for those slides or any other information, you can check it out there. But one of the things we were looking at, Kosu, was some of these other network policies, and you can find them. Actually, I'll put them up here. You can find them in the GitHub on network policy examples. So these are just some examples of things you can do with Kubernetes. So you can actually allow certain types of communication. So you can permit DNS access to your pods. You can allow front-end ingress, meaning that information can travel from the client side and the front end into your application, whether that can be login information or some kind of user response to something. And then blocking IPs as well you can do. So, for example, let's say you were trying to run Netflix or some kind of service where region is very important, right? You could restrict to certain IPs that are based on that. So, yeah, those are some of the network policy examples. But the reason we might want to apply a default deny network policy is to secure the cluster. So it's basically just, that's the reason why. And yeah, that way we can't just have someone trying to get access to our secrets or something like that. Yeah, keep that away. So, okay, one of the things I wanted to just tell you about is as we wrap up here, is just some troubleshooting. So we're going to look at some of the common things. So first, we would just want to say that sometimes a pod's readiness probe fails. And so what that means is that the pod is no longer saying that it's ready to go. If you look back in our deployment YAML, we provision readiness here. So we're saying that every 10 seconds, with an initial delay of 5 seconds, we're going to have a readiness probe tell about the status of each pod, right? And see if it's still healthy. And so there might be a failure of these sometimes. And so what we can do is use the following command. So we'll use kubectl describe, or get pods first. And then we have many pods. And so we can look at these by typing kubectl describe pod. Oops, copied too much, looks like there. And let's just use this here. And so you can see it says actually unhealthy. And so it can restart that. So this is a very good way to troubleshoot your cluster and troubleshoot your pods. And Kosi says, how do I run an existing Minikube container? Great question. So typically it should be visible in your Docker. So let's look at that. If you open your Docker desktop, I'll open mine and show you all. You can see I can pause this. So it should look like this to you when you open your Docker desktop. And it's kind of paused. And then you just push start to run that. And it'll spin up your Minikube. And then in order to actually get that going, you're going to want to type into your terminal, your VS Code terminal, or just your normal terminal, wherever you just make sure you're in the current directory of your cluster. You're going to type minikube start. Okay, so that's how you essentially get that going. All right, and so it looks like we have a little bit of a shorter one today, but I'm just going to give a summary quiz across all three parts. So we can now take a look at this. But which command do you use to create an autoscaler for deployment? That's the first summary quiz question. All right, looks like we are having an issue. So failing to connect. That is an interesting issue. I'm not sure about that, what the cause would be. Let me try to troubleshoot that for you. I'm just going to see what I can learn about this issue. Oh, okay, good that it works now. Yeah, it could be, it could be that you had some kind of different proxy where you are using a strange internet connection, or it could be that you forgot to start up your Docker desktop. Okay, yeah, maybe it just needed to run again. But the answer to this is that you would use kubectl and then your deployment. So I'll type that in. Nice that it's running normally, that's good. Okay, so here's another summary question for you. What object in Kubernetes stores configuration data without embedding it in the container image? So this is if we wanted to have some information, not necessarily something sensitive like an API key, but just if we want to store config data without embedding it in the image itself. So if we had a pod, actually, pods are embedded in the container image, because every time we run a new pod, it would explicitly look at the pod configuration, the pod YAML. So that would not be the answer. Any other thing that we remember, though, that could give us some information that we could apply in a decoupled way to all of our pods? All right, so I'll tell you, actually, it is config map. So config map is what we would use. And then, yeah, exactly. The temporary storage thing we saw earlier, this is another way we could do it. So we can actually have, yeah, that thing we saw during PVC, e-figure, yeah, ephemeral. So I'll say that. So ephemeral is temporary in computer science. And then persistent is the opposite, which means permanent. So these are just some computer science words to keep in your mind. If someone asks you, hey, I want to make a persistent storage. Well, that means they want to store something permanently or relatively permanently. As we know, nothing is permanent, but after the session closes, for example, they want to keep that around. And ephemeral would be like, let's just say you're playing a video game and the position of the character, that's an ephemeral quantity because we don't want to store all the positions of the character forever, right? Maybe we just want to store the health points or something like that. So config map is a form of ephemeral storage. Well, what you tell me. So config map, right? We have a file that has some information in it. And even after we close our pods, we can still load that in and it will stay the same next time. So is that ephemeral or persistent, would you say? So I'm going to say that's persistent because it's permanent. And here's another question here. Yeah, exactly. It's persistent because we can load it again. Exactly right. Exactly right. So cool. Awesome job with that. And name one method to secure sensitive information in Kubernetes. What's one method? Good answer there. Network policy. Yeah, we can use a network policy to block traffic and make sure that outside actors can't access, for example, our database of users. We don't want to expose our database of users that way. And another answer could be secrets. So secrets are a way we can store sensitive information. Now, one thing I'll say about secrets, because I do think it's so great that FASIC specified this, they're not encrypted. So you do have to remember that. And there's a great explanation in the chat of how to use secrets more effectively. And environments, that's another great example. So environmental variables. So you could even call that a config map, right? Because your config map, you could store your passwords or something like that in a config map. But just remember, and store some environmental variable, but just remember that's not actually encoded even. So it's not even encoded. So if you have an environmental variable, you probably don't want to store anything too sensitive in there. Maybe just your directory paths, for example. But that's a good one. And so what command would you use to check detailed information about a pod? This is the last thing we talked about toward the very end. Yeah, describe pods, exactly. So we'll use kubectl describe pod and then pod name, right? That's how we did it. So excellent work there. And the last question I'll skip because we already discussed this just a minute ago. What's the role of a network policy? It can be used to deny access primarily to certain communication ports and things like that. Ingress and egress traffic. So thank you all for your time today. I realize, unfortunately, we don't have. I didn't realize how short it was today. I guess I should have made it a little bit longer, unfortunately. But let me tell you about what's coming up. So I have a slide for what's coming up. I'm not sure why it didn't show. Yeah, thank you all for coming. And here's our next stream. It's with Abdullah creating a cloud-native CI/CD pipeline. So this is really dovetails nicely into our Kubernetes practice because you're going to learn about another DevOps concept called CI/CD. So continuous integration, continuous development. And yeah, we should have a little bit more time, as you said, Kosu, but I guess I forgot. Yeah, I think I just ran out of content. We went a little fast today. Yeah, FASIC, good point here. So it is a little bit of both. Yeah, it could be, it's ephemeral in the sense it can be updated and changed over time. Yeah, that's true. So yeah, thank you everybody for joining. And it was a great conversation, a great discussion. Can I show the secrets part again? Yeah, sure. So I will show you exactly where that is. We talked a little bit about it. So in this example, we stored a simple API key, and I'll show you that file, this secret.yaml file in VS Code, I can show that. Where is my VS Code? There it is. So if we go down to secret, the way we did it was we gave it some kind. So we said the kind would be secret. And then we gave it a default type. So we used the opaque type, and that was what we used for that. And then we gave it some data. So you can store not just API key, but you could also store other sensitive information. And because it's opaque, which is the default type of secret, it is base 64 encoded. So we want to base 64 encode the values when we define them in YAML, or we could use kubectl create secret to do that. So here's an example of how we would use that actually. Let's say that we had a password. I'll go into detail more here. Let's say we create a secret, and we'll create it generic. So we'll say my secret, and we'll say from literal, we give it a username admin. That should create a secret here. And then we will do password, and we call it pass123. All right, so this is not by default encoded, but by the fact that we, my secret password, let's call this then. But once we put that in, it will create an opaque secret for us that will be encoded in base 64 values. All right, so that's a great example of how to do that and how to use that. All right, great. So yeah, thank you all once again, and I think we had our next one. Oh yeah, don't forget to run your apply command to apply your YAML configurations to these. Okay, no, another question here. Anything after the secret is created? You probably don't have to apply after the secret is created, because the apply is to apply YAML configurations. But yeah, thank you all for joining, and yeah, I hope you enjoy the next stream, which is, I believe, Abdullah's stream with CI/CD pipeline. That'll be great for anyone who's continuing to learn about that. No problem. All right, take care, everybody.